In this lesson, we're going to discuss how to find an equation for a line tangent to the graph of some function f of x at the point x1, y1. So for example, let's find an equation for the line tangent to the graph of f of x equals 3x squared minus 5x plus 3 at the point where x equals 2. So notice that what I've asked you for is an equation of a line. Well, a typical form for an equation of a line is the point-slope form. Y minus y1 equals m times x minus x1. So if you have a line of slope m that passes through the point with Cartesian coordinates x1, y1, then its equation can be written in the form y minus y1 equals m times x minus x1. Alright, so we're going to need both a point and the slope. Well, the point is not exactly given to us. We're given some information, but not all the information. We want to find an equation of the line tangent to this graph at the point where x equals 2. So at this point of tangency, what's going to happen is, and I'm not saying that this is an exact representation of what's going on, but you're going to have a situation kind of like this. You'll have a graph f of x, and then here is the tangent line at this point. This tangent line and the function share a point. They may share more than one point, but in our case, I've told you that the x-coordinate of the point we're interested in is 2. So the point where x equals 2 lies on both this the graph of the function and on the tangent line. So we can use this point to fill out the details in our equation. So we know that x equals 2, so x1 equals 2. But now what about y1? What's the y-coordinate of this point? Well, this is where we use the fact that the point lies on this graph. You know that if you know the x-coordinate of a point on this graph, that to find the y-coordinate, you just substitute the x-coordinate in. So that means in our case that y1 is going to be f of x1, which is f of 2, which is going to be 3 times 2 squared minus 5 times 2 plus 3. 3 times 2 squared is 12, and this is minus 10, and then plus 3. That looks like it's going to be 5. Alright, so we've got the point then has x-coordinate 2 and y-coordinate 5. Well, what about the slope? Well, the way to find the slope for a curve is to use the derivative. In this case, the derivative, using the rules that we've discussed prior, is going to be 6x minus 5. And to find the slope, we substitute in the x-coordinate of the point that we're interested in. And that should give us that the slope is 12 minus 5 is 7. We've got all the information we need now. Going back to our point-slope form, what we're going to have for our equation is y minus y1 is equal to the slope times x minus x1. Alright, we can clean this up a little bit. So y minus 5 is equal to 7x minus 14. And then that cleans up a little bit more to y equals 7x minus 9. And there you have an equation for the tangent line.